All right, first up on our quest to analyze and sketch graphs, complete graphs, we have f of x is equal to x divided by square root of x squared plus 2. Now, this looks maybe similar to something that you've graphed in the past. It looks sort of like a rational function, but technically this one is not rational because down here we have a square root. It's not a polynomial. All right, so there's no like SRT transformations that we can call upon in order to do graphs for this kind of thing. Instead, what we're gonna need is a little bit of calculus. Prior to using the calculus though, let's start with some algebra. Namely, what is the domain? Well, we know that when we're calculating the domain, when we're trying to figure it out, we just ask ourselves, what can x not be? Well, we've got square root here down in the bottom. So first of all, it can't be 0, and square root means it can't be negative. So I would take something like x squared plus 2. Ordinarily, if it's just square root, it has to be greater than or equal to 0. But since this is in the denominator, it's got to be strictly greater than 0. And maybe you just look at that and go, oh yeah, that's always going to happen. If I subtract the 2 over, maybe now you can see that that's always going to happen. X squared, when we square a number, a real number, it's always going to be greater than a negative 2. What's that mean? That means our domain is, that's not how you write all real numbers. That's better. It's all real numbers. This means that there are no holes or vertical asymptotes. No holes, vertical asymptotes. Okay, that's handy to know. And as far as the range goes, well, I may have to do a little bit more investigation in order for me to see how high up this thing goes or how far down it goes or whatever. Let's consider maybe not asymptotes yet. We already said there's no vertical asymptotes, but that doesn't mean that we don't have a horizontal asymptote. Let's do intercepts. So as far as intercepts go, you've got either where x is equal to 0 or where y is equal to 0. You know what's super easy? It's just plugging 0 in for x so you can find the y-intercept. So let's say x is equal to 0 gives us f of 0 is equal to 0 divided by square root of 0 squared plus 2, which is just 0. We have the point 0, 0. This is both the x and the y-intercept. And it only has one of them. If you have an x-intercept of 0, then your y-intercept is also 0. Usually when you're finding the y-intercept, you set the whole thing equal to 0. Whoops. If I set this thing equal to 0, I'd get x on the top, square root of x squared plus 2 on the bottom. You'd multiply the square root over, and you could see that it's x is equal to 0 also. So there you go. Hey, why not go ahead and scroll down here, and then let's go ahead and put a dot there. All right, we are well on our way to a complete graph. Anyway, okay, well, mention something about horizontal asymptotes. Horizontal asymptotes, they happen or possibly happen where x is approaching positive or negative infinity. But it's also possible that you just have infinite in behavior, that it's going to go up or down. In either case, we're going to find that out with a limit as x approaches infinity of that function there. So we've got x over square root of x squared plus 2. Once again, all right, if I were to stick in an infinity here, I'd have infinity on the top. I'd have an infinity down here on the bottom. So it's infinity squared plus 2, still infinite. Square root, still infinite. I get infinity over infinity. What does this mean? This means it's a check for L'Hopital's rule. All right, so let's take the derivatives of the top and the bottom. Let's see what happens. So limit as x goes to infinity. 1 on top, that's real nice. And on the bottom, I'm going to have 1 half, let's see, x squared plus 2 to the negative 1 half, and then multiply it times 2x. Okay, let's do some cancellation here. Beep, beep. This x down here is going to stay, but since this is a negative exponent, then that means that this thing goes back up to the top, which means I have limit as x goes to infinity of the square root of x squared plus 1 over x. Well, that's weird. It just kind of flipped over. Well, what would happen if I were to stick in infinity again? Well, I have infinity up there. I have infinity down there. This would go to infinity over infinity. Hey, guess what? It's a check for L'Hopital's rule. Okay, so let's find the derivatives of the top and the bottom again. So I have the limit as x goes to infinity of 1/2 x squared plus 1 to the 1/2 power, no, negative 1/2 power, times, chain rule, 2x all over 1. Okay, get out your cancellation crayon once again. Cancel, cancel. This x will stay up on the top, and this square root will go down to the bottom. Hey, should be blue. I have x on the top, and then the square root of x squared plus. How did this turn into a 1? How come nobody was paying attention to this? Should have been a 2. Should have been a 2. All right, well, I caught my error. Not that it mattered, because look, we went into a giant circle. This thing is never ever going to end, which means that you can't use L'Hopital's rule to resolve this particular limit. What do you do then? Well, you go back to our trick, and that trick was to divide the top and the bottom by the highest power of x that's in the denominator, which is going to be the square root of x squared. Square root of x squared is just x. So we're going to divide both the top and the bottom by x. So I've got the limit, once again, I'd have x over x divided by the square root of x squared plus 2. Remember, it is a 2 over x. But I'm going to think of that x that's in the bottom as the square root of x squared. Now remember that the square root of x squared is actually equal to the absolute value of x, okay? Remember, it neuters it. That's going to come into play whenever we have to do the limit as x approaches negative infinity. All right, across the top, what do we get? Across the top, I get 1. So I get the limit into 1. And on the bottom, I have the square root of, I can bring this x squared that's in the denominator down here, inside here. That would be 1, and this is 2 over x squared. All right, I could go ahead and take the limit. The only thing that's going to be affected by that infinity is this second term down here on the bottom. That's going to go to 0, and I have 1 over the square root of 1, which is just 1. That is a horizontal asymptote because it's a finite number. It's not infinite. It's not infinite. It's not infinite. So this is a horizontal asymptote. Why don't I go ahead and put that in there on the graph? Oh, well, look how convenient this is. Right here towards the top of my graph, I have 1. Okay, whatever. All right, and now I have to do this one more time, and that is for negative infinity. Right, you have two ends, so you have to check both of them, positive and negative infinity. Limit as x approaches negative infinity of this same exact function. All right, now, L'Hopital's rule, not going to work on this one. Once again, we're just going to have to do this trick right here. And notice that it's going to be exactly the same. It's going to be exactly the same, except for right here at this step, I need to make sure that I bring this negative on the outside because the square root of x squared is equal to the absolute value of x. But in this case, our x value must be a negative number, and there's no way that the square root of an x squared is going to give us a negative number. So we have to make it negative. So this one is equal to the limit as x approaches infinity, x over square root of x squared plus 2 over negative square root of x squared. I don't have to worry about the negative sign on this one because, whoops, another mistake. But I caught it, so it's all good. All right, anyway, so this negative is like I don't have to worry about putting an extra negative sign on this x because the limit takes care of it. It didn't take care of this one because it got neutered in the process of squaring and taking the square root. All right, all this to say that this is equal to the limit as x approaches negative infinity, 1 on the top, Square root of 1 plus 2 over x squared. Don't forget about the negative sign on the outside, which means that this one's going to go to -1. Ah, another horizontal asymptote. What do you know? Let's go ahead and dash this one in here. Doop, 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 doop. Like I said, how convenient is this that the graph just happens to have a range from positive to -1? Hey, notice I said range. Does that mean like we can't go beyond, like we can't cross one of these horizontal asymptotes? Well, you can. You cannot cross a vertical asymptote, but you can cross a horizontal. And maybe when you were in pre-calculus, you asked yourself this question, like, how do I know whether or not I cross it or not? Am I supposed to just guess? Do I have to look it up on a calculator? No, you don't. What you do is you just set your equation equal to its horizontal asymptote, because if it's equal, here, let me just get out like a graphing color, which is officially green here. If my graph did something like this, then that means my function must be equal to 1 someplace. So I just check to see if that happens, either equal to +1 or equal to -1 for the bottom one here. So does f of x cross y is equal to plus or minus 1? Question mark. Okay, so all you got to do is x over the square root of x squared plus 1, no, plus 2, is equal to 1. All right, you got to do it separately, right? Is equal to plus or minus 1? Nah. All right, so we're going to cross multiply there, and I'm going to have x is equal to the square root of x squared plus 2. Pardon me. All right, so how do you solve this equation? Well, you square both sides. So on the left-hand side, I have x squared, and on the right-hand side, I'll have x squared plus 2. And now if I subtract x squared from both sides, I have 0 is equal to 2. What does that mean? It means a whole bunch of nonsense, and it means that f of x does not cross its horizontal asymptotes. Well, I only checked one, but let's see what would happen if I throw in a negative sign here, huh? If I throw in a negative sign here, that'd make this thing negative, and then when I square both sides, then it becomes positive again, and I can see that it does not cross either positive or -1. All right, I think that's pretty good for this particular video, and then when we come back, we'll take a look at some symmetry, some possible symmetry, and then do some calculus on it. Yeah? Okay.